Recently, my family and I visited New York. There were so many places to go to: the Met, Statue of Liberty, Central Park, and others. We had only one day, so we wanted to walk the shortest distance possible, so we started at our hotel, visit all the places we wanted to go to, then returned back to the hotel. How would we plan our traveling routes so that we use the shortest possible path? This is a version of a question mathematicians have been trying to solve for years. This question, known mainly as the traveling salesman problem, is generally stated as a problem in which a salesman has to find the shortest path he must take from a city, visit a bunch of other cities once, then returning to the original city. It was formulated by Irish mathematician William Rowan Hamilton and British mathematician Thomas Kirkman in the 1800s. However, it was first studied by Carl Menger, a Harvard professor in the 1930s, who considered a brute force algorithm in which one tries all possible routes and finds the shortest one. The maximum number of tries needed to find the optimum path for n places is known as n factorial, or n times n minus 1 times n minus 2 all the way to times 2 times 1. Now consider our beginning example with 10 places. What if the places are arranged differently? Or if there are 5 places? Or if there are 30 places? We find an algorithm that can find the shortest distance that a salesman needs to travel in any possible situation? Sadly, this is still a question to which there is no answer. However, there are many different algorithms that use logic to parse possible combinations of routes and find the smallest one. An example is a greedy algorithm, in which the salesman constantly goes to the closest city. This algorithm often works on small sets, but gets worse on larger sets. For example, if there's an outlier, there's a chance that the algorithm will not even include the outlier in its path. However, one of the shortest algorithms wasn't discovered by humans. It's used by bees. Bees use a special algorithm in order to find the shortest distance between flowers. In experiments, the bees take only 20 tries to find the shortest route between 5 flowers, while a brute force algorithm would take 120 tries to find the shortest route, 6 times the amount of tries a bee would take. All in all, the traveling salesman problem, though unsolved, still has many applications in the sciences as well as math. For example, it is used in DNA sequencing to find out how similar a set of DNA segments are. It is also used in the production of microchips, to determine the minimum amount of wire needed to connect the terminals. Furthermore, there are other variations of the traveling salesman problem. One example is the traveling purchaser problem, in which a customer has a list of products he or she wants to buy, and must find the path from store to store that minimizes both the cost of travel and the cost of the purchases. Another example of this is the traveling politician problem, in which a politician has a list of states to which he or she has to travel to. Each state has a bunch of cities, and he or she must find the minimum route so that he or she visits a city in each state. So next time you're going on vacation or looking for a better deal, maybe you will be able to solve the traveling salesman problem.